Alrighty guys, kind of a big problem here. We have a concave mirror. We have some distance or radius of curvature, which is 16 centimeters. We have a candle that's 38 centimeters away. We are basically asked, okay, what is the focus point of all the rays? So where are all the rays focusing to or passing through when they're being reflected? Where is the image that results from this candle? And is it upright or is it inverted? That's what we're trying to find today. So let's go ahead and figure this out. I'm going to redraw the candle. I want it to be above the radius of curvature. So let's assume the candle is right here. So where is that image going to be? What we have to do here is draw a simple ray diagram just to kind of understand, okay, where's this candle going to be? The first one, and let's draw in our focus point, which we'll call right here. That's going to be the focus point. So the first ray comes in parallel, goes through the focus point. Let's also make this one that goes through the focus point and gets reflected like this. So the image is going to end up here. And we're going to see if it's upright or inverted, but this is going to be that final distance. And it's going to be somewhere with respect to D0. I'm not really drawing this to scale. It could be further than it, before it. I don't know yet. I have to do the math to figure it out. So let's solve part one. Where is the focus point? Well, notice that R equals 2F. That's a fundamental law of mirrors, that the radius of curvature equals 2 times the focus point. So if we just do the math, we just divide the radius of curvature, which is 16 by 2. So F is going to equal 16 divided by 2. Oh, geez, what is that? 3, 5, 8. Is that right? Am I being stupid? Am I being stupid, Corbin? No, I'm not. So the focus point is 8 centimeters. Sorry, I suck at mental math, but hopefully you know that R equals 2F, such that F is 8, to make that equality true. Okay, and now we need to know where is the image. That requires another formula. We know that this formula is true. Hopefully you've seen a proof for it. I won't get into it now, but 1 over the distance initial plus 1 over the distance of the final image is equal to 1 over the focus point. So let's plug everything in. We know that the distance initially of the candle is 38 centimeters. We don't know where the final image is. That's what we want to know. And we know that that's all equal to 1 over F, which in this case is 8 centimeters. I am not going to be able to do that in my head, so let's just do it on the calculator. 1 over 8 minus 1 over 38. That's going to be that 1 over df is equal to 15 over 152, such that df is roughly equal to 0.099. Does that make sense? Does it? No, it does not. Or sorry, 152 over 15. Sorry, I put it in wrong. I was like, it can't be point something meters away. Okay, the distance final is 10.1. And how many sig figs? We have 2, so we're just going to say it's 10 centimeters away. So where's the image? I need to erase some things here. That's just going to be 10 centimeters. Okay, so hopefully you're able to follow that. It's just plugging and chugging here using this formula. I think the hard part might be understanding to use that formula. So it's 10 centimeters. And is it upright or inverted? Now, there's 2 ways that you can think about this. You can draw the ray diagram from multiple points. So we could even draw one here. Maybe draw, if it's parallel, we draw it through the focal point. It comes out. And then we could draw another ray that goes up and goes through the focal point. We would see that it would make an inverted image. I believe that's how it is. But the way that we can actually figure out for sure is using this formula that the magnification equals negative the virtual image over the initial image. And you might be saying to yourself, okay, why am I using this? Well, not only does it give you magnification, so how much is it blown up by, it also gives you the relationship of inversion or uprightness of the image. Now, if you get a positive answer, you're going to get an upward image. If you get a negative answer, you're going to get an inverted image. So the things are going to flip around. In this case, distance finals 10 centimeters, a whole real number, over distance initial 38, a whole real number. Positive, sorry, I should say they're both positive. So two positives, we know m is going to be a negative number, and that's going to tell us that the image is inverted. So if you're able to follow that, if you were, please drop a like, comment, and subscribe. That's going to be the end of this one, and I hope that you have a wonderful day. Bye-bye.